We are live. Welcome, everyone. We are actually live 1 minute earlier. So, welcome to everyone who's already there. We are going to be talking about DICOM today. If you are already live, drop us a comment there so that I know that you're there and we can get down to business with my guest, David Clunie. Dr. Clunie, how are you today?
I'm well, thank you.
Fantastic. So, I already started talking to you before we even went live, and there is a part of conversation that was missed by our guests who are already listening to us, but it doesn't matter because we're gonna dive into it again. And I am seeing some comments. Let's see. I see that people are here, which is fantastic. So we are going to be talking about DICOM. It's 12:15 officially. My guest is David Clunie, who is to me Dr. DICOM, Mr. DICOM. It may sound funny, but I learned about DICOM from you, David, at the ESTP conference in 2019, and I actually briefly got involved about in your working group for DICOM annotations. Um, but you are the ultimate source about DICOM knowledge for me. How are you today?
I'm well, thank you.
And we have people joining from Canada, and people are live and thrilled. Fantastic. Drop more comments below. Where are you tuning in from? I want to see where in the world you are. And before we dive into DICOM, I need to address this, David, because everybody who saw your LinkedIn picture saw that you're in a helicopter on this picture. Can you tell us about this helicopter?
Oh yeah, that's my little helicopter that I fly around sort of for fun in the afternoons when I'm finished working. And it's a Hughes 269. It's from the 70s. It was a military trainer.
You have this helicopter is from the 70s?
Yeah, it's 50 years old. Yeah, it's older than you are probably.
Yes, it is older indeed. So is it not like bad vehicle? If I had a car from the 70s, it probably wouldn't
No,
be too
no.
good.
Well, I mean, aircraft are looked after much more diligently. They have regular inspections. In fact, my helicopter is in pieces all over the floor of the hangar at the moment because it's undergoing its 48-month inspection at the moment. So um, they're looked after very carefully, and any worn-out parts are replaced, and there's no corrosion or anything like that. So it's just as good as it came out of the factory, pretty much.
Oh, wow. Okay, fantastic. I see people coming. We have Phoenix, Arizona. We have Ireland. We have Lyon, France. We have Italy. We have the globe. So thank you so much for joining. So let's start. David, let's start with what is DICOM. Let's start with what it stands for, and let me tell you why I'm asking this question. Because for a long time, even when I was involved in the annotation group, I thought DICOM was an image format. Can you tell me what it is and how it actually differs from an image format?
Well, it is an image format, but it's much more than a format. It's a lot of things, and DICOM existed before it was an image format, to be honest. So the fundamental problem that DICOM tries to address is the interchange of image information. So you have an image in one place, and it needs to be used in another place, and that requires two things, essentially: the transfer of the pixel data that constitutes the image, and the information about the pixel data that tells you who it is, when it was taken, what it is. You know, this is an H&E slide as opposed to a CT scan of the brain, for example. And it was acquired on the 23rd of July as opposed to, you know, some other time. And it's about me and not you, and all the kind of management information that's necessary to actually use it in a production clinical environment. So back in the 70s, when digital imaging was first taking off in radiology, people realized that they had to move images between scanners and imaging systems for viewing and storage and analysis and so on. And so they needed a means to move the data around. So DICOM is that means. It stands for Digital Imaging and Communications in Medicine. And so it tries to do everything necessary to achieve that goal. So just as when you use the internet or the web or whatever, There's more going on behind the scenes than merely looking at text or looking at pictures. They're arranged in a pattern, and that pattern's defined by a file format called HTML, hypertext markup language.
Mm-hmm.
And you're reading it, you're viewing it in a web browser that's talking to a server that serves up those HTML pages, and that's using the HTTP protocol, the hypertext transfer protocol. So every interaction from your phone, from your tablet, your car, everything that talks to another device is exchanging information using protocols. And sometimes that information can be then stored into a file in what we refer to as serialized, for want of a better word. So we can save a web page. We can store that web page. Mm-hmm. We can print it to PDF, or we can save it to HTML with all its attachments, and then reopen it later. So DICOM is just the same. So DICOM is like the web protocols. It can store information in a file or set of files that are related.
Yeah, and I'm going to ask you about this file or set of files.
Absolutely, yeah, that's a very key,
in mind.
That's a very key point. Yeah.
Okay, so let's say in very simple words, like how does it differ? So we're talking about DICOM for pathology. Pathology is kind of, some vendors are starting to scan right in DICOM. The image analysis community is asking, and we have a question about that. So for everyone who's here, drop down your questions. I'm going to be showing them as we speak. And one of them is about putting DICOM in the context of biomedical informatics. Before we answer that, I wanna talk about image analysis. But before we talk about that, let me go back to this. Let's put it in a very simple way. How does it differ from, let's say, a super popular digital pathology image format is SVS coming out of Leica Aperia scanners? How does DICOM differ? What's common? Can you put SVS in DICOM? Like, how do you work with it?
That's a very good format to pick, both because of its popularity and longevity, but also for two other reasons. One, because it's based on TIFF. So an SVS file is actually a TIFF file that Leica has crossed out TIFF and written in SVS. So it is a TIFF file. And if you use a TIFF library, you can read it. And if you use a TIFF viewer, you can look at it. Not the way a pathologist looks at it, but you can open it. And the second thing is that the people who wrote SVS in Leica wrote the DICOM format, in essence. So DICOM works by consensus of users and vendors. And
what a coincidence!
So when the manufacturers are making products and they want them to interoperate, they come to DICOM and they say, hey, we need a solution for this problem. Or the users come along and say, hey, vendors, we need you to solve this problem. So working group 26, which is a DICOM pathology working group, somebody asked about that, is the group that defines the extensions to DICOM that support pathology. And when those are defined, which they were back in 2000 or so, this was added to the standard.
I need to stop you. What are extensions? What do you mean with extensions to DICOM?
Well, once upon a time, people took X-rays, and that was the only kind of radiology image there was. And then they had ultrasound, and then they had CT, and then they had MR. And as new modalities come online, the standard gets extended with specific capabilities to support them. So as you can imagine, there's lots to say about a CT scan that's different from what you say about an MR scan, and there's lots in common. They both have a slice thickness, they both have a position in the body, but one has an echo time, the other has a kilovoltage, and so on and so forth. So we use the basic core of the standard to support all image formats, and then we have specific capabilities. I won't go into the formal terminology, which would just be confusing, but extended features and capabilities dedicated to a particular purpose, so that when you are buying a pathology product, you can say to the vendor, I want you to do not just DICOM, but I want you to do the DICOM whole slide image.
Okay.
Because that would be different from someone doing gross imaging, because what they need to do for gross is different.
Okay, so first of all, question to the audience. Are you hearing us well? And is everything fine on the tech side? I should have asked this at the beginning, because if it was not okay, you missed like 10 minutes of the broadcast. But I assume it's okay because I saw some comments. But just drop me a yes if you're hearing us okay. And now, okay, so you say me as a user or somebody who's considering buying a solution, I can ask the vendor, listen, I would like DICOM whole slide image, and there's an extension for this, right?
Yeah, except that we don't really call them extensions. I've used the term loosely. We extend the standard from time to time, but the DICOM standard is whatever it is today. There is no version, there is no year, it just is, and it gets bigger. It's sort of like a cancer that takes over the world, if you like, or a virus, depending on how you look at it. It is what it is.
That's your goal, right? For DICOM to take over the world.
Absolutely, yeah. We are the Borg. We will assimilate you. Yes, absolutely.
Okay. Fantastic.
And so the reason that we do that is because technology changes, but we use the same core principles, and this is the advantage of using DICOM. You can store your pathology images in the same archive that you store your CT images, if it's generalized enough. And so the enterprise IT people can take care of your storage and your backup and your security and your business continuity and your disaster recovery and your multi-site replication and your storage in the cloud, because to us DICOM folks, a pathology image is just a big DICOM CT image, except it's stored slightly differently with certain characteristics. You need dedicated software to view it, to analyze it.
Which we're going to talk about. There's a question about that as well.
Yeah. But ultimately, the whole benefit of using DICOM is that all of the metadata, when you put your name in a CT image, it's stored in exactly the same way as your name in a pathology image, or an ultrasound image, or an ophthalmology image, or a dermatology image. All of this common metadata about you is stored the same way, regardless of modality. Go ahead.
So now a question about that. Can we detach the metadata from the image?
No.
I'm
No.
I'm asking because often for artificial intelligence model development and for image analysis, when you have data coming from different sources, it's okay to use the pixel data, but it's not okay to use the metadata in case.
Understood. Yes, you're talking about de-identification.
Yes, I'm talking exactly.
I'm just finishing up a 100-page report on medical image de-identification, including whole slide imaging, which I will share with you when the time comes. But
I'm going to interview you about that as well.
The important thing is you can't say that it's Alessandra's whole slide image for research, but you do still need to know it's H&E. You do still need to know it's FFPE or not. You do still need to know that it's 40x, not 20x, and so on.
Okay,
so all
like
the metadata,
the personal information gets stripped off. The other information that's necessary to even handle and do anything with this image stays.
Is preserved, exactly. And that's part of the art of de-identification in secondary reuse sharing of clinical data. Or clinical trial data for that matter. And so instead of your name, there will be a pseudonymous identifier, but it will still go into the same field. So from DICOM software perspective, it doesn't care that it's been de-identified. All of the requirements to manage it are still kept, because in an experiment, you still have 10 patients, 100 patients, 1,000 patients. They have to be numbered. The numbers have to be linked to outcomes data, whatever is relevant to the clinical investigation, even though it's been de-identified. So we use the same metadata for clinical data and research, and this is where we have some pushback from the research microscopy community, for example. They're used to using pure research formats with no metadata, unmanaged, just named by file name or folder on the disk, whereas DICOM insists upon metadata being present and pseudonymous identifying metadata in a research context, real identifying metadata in a clinical context, because the same systems are used, the same software is used, the same archives are used, and we don't want to have this division between research and clinical. We want to have the same formats used everywhere.
So question, why is there pushback? Is it more work to, why do they push back?
From a vendor's perspective, from a vendor's perspective, it's always easier to make up homegrown stuff. And there's nothing a programmer, and I'm a programmer, likes to do more than write standards for themselves. So everybody makes up their own new standard because that's fun. Some of us succeed and some of us don't succeed at that. It's always easier to do only as much as you need to get the job done. and you focus on what is necessary to satisfy your immediate customers without a view to long-term interoperability, without a view to having multiple vendors working in the same environment. So, if you have a lab full of Leica scanners and nothing else, okay, fine. There's nothing wrong with eSlide Manager and SVS format and so on and so forth. But the moment you send it to somebody else, you're in trouble. If you send it to a Philips site, they can't read it and you can't read theirs, and so on and so forth. So somebody needs to make a choice, and we recommend in DICOM that you make the same choice that every other imaging modality has already made, which is to use DICOM.
Okay, so this is a good place to ask a follow-up question that I have planned for later. But what about viewing those images? I have seen in your description on LinkedIn, you are an author of an open source DICOM viewer, which you just told me is not for pathology images.
No, I don't write viewers. That's not my forte. I write toolkits which enable other people to write viewers and so on. But my interest is mostly in the mechanics of the standard behind the scenes. And I may be a radiologist, but I don't do radiology anymore. I haven't for decades. I'm more interested in the machines, and I'm not very good with people. So I like to stick to the programming.
Thank you for joining us live. Thank you. In spite of this characteristic.
In spite of this characteristic, yeah. But no, other people write viewers, and they write very good viewers. And some are open source and some are commercial. Some support DICOM, some don't. And for those that use general libraries, one of the benefits, if you like, of having a plethora of different proprietary formats in pathology is that we have libraries like OpenSlide, Bioformats.
What's a general library? Let's be super simple.
So suppose my use case is I want tile number 38, and I'm going to do image analysis on it, machine learning, whatever. Tile number 38 in an SVS file or a DICOM file or any other format file may be the same physical thing conceptually. It's a tile in a layer in a pyramid. But it's encoded in different ways by different vendors in different file formats, and it can be encoded in DICOM, and it can be encoded in TIFF, purely generic TIFF. So a library has an API, application programming interface, or something like that, which one uses to request the tile one wants, irrespective of the format it comes in. Either this location, or this numeric offset, or this three-dimensional location, whatever it is. And so the library abstracts the proprietariness of the format and allows you to do the same thing with multiple different files in multiple different formats. So an application like QPath, for example, which is very popular, I guess, in your community, uses bioformats and OpenSlide to do the actual work of reading the files. So amongst those of us who use DICOM in research for pathology, we have contracted to extend bioformats to support DICOM reading directly. So as far as bioformats is concerned, a bunch of DICOM files are the same as yes, I just saw the comment that QPath is free, but it does not support DICOM. Well, it actually does. It depends on which version of QPath you use, and more importantly, which bioformats library version you use. So this is a relatively recent addition. And furthermore, in the last bioformats library, they screwed something up with respect to SVS handling, so they had to fall back to a previous version that doesn't have DICOM support in the current version of QPath. So there's a dependency issue there, but in principle it does. We're also
every now and then I'm going to be just showing the comments, and you can address them if they fit into what we're talking about.
Yeah, and just to finish off on that topic, OpenSlide as well has long lacked DICOM support. So we have we're getting the OpenSlide people to add it now too, because there's a bit more development on OpenSlide actually happening again, which is great news for everybody. And that'll give you reading capability, and bioformats can also write DICOM, which is another good feature.
Okay.
You mentioned something before that I don't want to forget, and that is the DICOM is a set of files.
Yes, let's talk about that. And just to address, we have a lot of questions. I'm not sure if we're going to be able to address all of them, but I will definitely compile them. And David, if it's okay with you, to work on the answers to those questions that we don't address in the live stream, because I am happy to see them, because there is a little bit of confusion. And
and they're very good. They're very good questions, and furthermore, they're questions that indicate an experience with at least attempting to use DICOM. So that's very good.
We're trying hard.
Absolutely. So let's go back to the file set
Yeah.
question. Ask your question. Yeah.
File versus file set of files. How does that? What is it?
Right.
Why do you have a set of
So
files? How do you make them
because
together?
DICOM is not inherently a file format, and normal DICOM systems actually manage all of the data. We don't get too upset when we have a dozen files to solve a particular problem. So as you know, a whole slide image is usually represented as a pyramid, and it has different layers, and within the layers are tiles. Now you could imagine a format where every tile was a separate file, and that was originally there was one proposal to do it that way. Or you could combine all the tiles in all the layers and the label image and the overview or macro image, whatever, into one file, and that's what SVS does, for example. So TIFF allows you to stuff multiple
like
images
have the pyramid all together and zoomable
in one
instead
single
of
file. Yeah.
Switching. Yeah, I
Right.
think that's what most users are used to, and probably because SVS does it, because and we're most used to this digital.
But the problem is users should never see the file. Like when you take a photograph with your digital camera, you don't see the file. I mean, you can dig it out if you really have to. And when you share it with someone, it gets shared via a cloud service. You don't see the file. You send a link and so on and so forth. So DICOM anticipates that everything is, quote, managed. So whether it's one file, 50 files, or 1 million files, the DICOM standard doesn't really care as long as the information model is correct. When you are moving files around on disk yourself, that is less convenient, but you zip them up, so then you have one zip file that has a lot of DICOM files in it, or whatever. But each layer in the pyramid is stored in a separate DICOM instance, as we call it, file. The label is in a separate instance file. The macro is in a separate instance, and so on. And the annotations are in separate files. We never mess with the image files themselves. When we make annotations, we store the annotations in separate instances.
And that's also what I know from the XML. So SVS and XML together, the Leica type of annotations from Apereo Image Scope. You can draw on the image, but it's actually a separate file. If they go together, they open together, but one doesn't do anything to the other one.
Yes, the key is they go together. You have to manage them together. Yes.
Yes. So then there's a question that we have on the screen. Is the DICOM file format from 3D Histech identical to other vendors? So that's a general question.
That's an extremely good question. And the answer is yes and no. Yes, it is, in the sense that
fantastic answer.
It is in the sense that it follows the same principles. It has to comply with the standard, otherwise it's not a valid DICOM file. But the DICOM standard is flexible, and this is where you run into issues. So for example, imagine that you are encoding cytology. So you have clumps of little cells kicking around on the slide, widely separated by enormous amounts of white space. So it makes sense to say, I'm going to encode these frames where these cells are. I'm going to leave out all the white space until I get to the next bunch of cells, and then I'll encode them. So there's a relatively sparse encoding mechanism. And furthermore, in cytology, you want Z depth. You want multiple Z planes, typically. So you're encoding multiple Z planes. Now, that's very different from one chunk of tissue on a slide that's occupying most of the tissue area of the slide that's been scanned in a logical raster pattern, which what we refer to in DICOM as tiled full. So you don't need to describe the position of every tile if it's completely predictable, and you're encoding every tile. Now, the empty space can be compressed extremely efficiently, so it's not taking up much space, but it's still encoded. So in that sense, you could have two perfectly valid scans of a slide, one with sparse tile encoding, one with rasterized full encoding, and they would both be valid DICOM. But a viewer or an analysis tool might not be capable of handling both of them, because the viewer may be designed for only cytology or only full slide imaging. And so to that extent, those kind of variations cause fundamental failures in interoperability, whether you're using DICOM or any other system. But also there are minor details. So if one writes a viewer or an analysis tool, it's dependent on the presence of a very specific feature, particularly when it's an optional feature. For example, the nominal objective power, is it 20x or 40x? And normally, pathologists like to see that on the screen. But some people might not fill that in. So one vendor might not put in a value for that. And so there's no objective power shown on the screen. Now you can figure it out from the size of the pixels because that is specified in terms of microns, and you can compute a sort of pseudo power. It might be 39.8 instead of 40, which bugs the crap out of some pathologists or not. But those are the kinds of things that vary between implementations, not just between vendors, but different versions of the same software or the same hardware from the same vendor may have variations in this respect. So that's why I say yes and no. Yes, it's still DICOM. Yes, it's still usable. Yes, it's probably still compliant, assuming they followed the standard properly. But no, there may be variations that cause interoperability failures because of sort of second and third order issues that are legitimate flexibility.
Okay, so we have one granular question that I'm going to show on the screen, but before we answer this one, I want to ask you, so, okay, DICOM is flexible, you can do one file, you can do many files, but what's the path? Like, if I'm a pathology, no, like, what's the recommendation from you for the pathology
very
community?
Simple. Pathologists should not have to worry about this crap. Pathologists should just be able to go to their vendor and say, I want a scanner that A, does DICOM, B, stores the images in any archive, and C, works with all of the following viewer and analysis tools that also claim to do DICOM that I want to use.
Mm-hmm.
And that's what you should do. No more, no less, because you don't need to know the details.
Yeah, I don't want to know the details.
Exactly, yes.
But then I need to go to my scanning vendor to say, no, to let's say several scanning vendors that are in my organization. And I ask them to do DICOM for me because I want to use those several, I'm showing 3 on my fingers for each of these, image analysis solutions and QPath as well, because it's free. That's like, and they're asking me, what do you want exactly? And I don't know what I want exactly.
Well, tell them what it is you want to do. So, for example, suppose you want to do KI67 automated analysis that kicks out one of the scores you guys like and shows me the membranes on the screen or whatever as annotations. So that triggers a number of requirements. First, the images have to be in an appropriate form. The metadata defining that this is KI67 and not H&E has to be appropriate. The management information for the patient has to be tracked so that the output will have the patient's name on it, for example. And then you need to be able to encode the annotations in DICOM formats because that's where you say where the membranes are. And then you need to be able to encode the KI67 score in something interoperable. Now, it's not an image, it's something, maybe it's beta in an HL7 message or FIRE or something. Could be done in DICOM, but that's probably not the best format. So you need to tell them what you want to do from beginning to end, and then they can define what we refer to as the interoperability boundaries, and then say, well, we're on this side of this boundary, we do this service, and then we then compare with the other 3 vendors that you want us to talk to, and we need to make sure they do each of those 3 services as well. And we define all this in what's called a DICOM conformance statement, and the customer's job is essentially matching up the DICOM conformance statements to make sure that they align, that the images produced by the source are consumable by the sink and have the necessary information in them. This is a level of maturity that's widespread in the radiology industry, not in the pathology industry yet.
Good for you guys.
Well, we've been doing it for 35 years, so I mean, it's we have a bit of a head start.
Okay, let's take
and it's a lot easier in radiology, frankly.
So let's make a little break with the question that Maria asks us. JPEG is preferred image format, but it sounds like it doesn't matter what the format is, and more so
yes,
if it meets that requirement.
Very good question. A very good question, because this leads to a key concept. When you look at an SVS file, for example, it can contain JPEG compressed tiles or JPEG 2000 compressed tiles, or theoretically some other format compressed tiles. Leica have for a long time been quite content to use baseline JPEG, just as your digital cameras you use in your phone do, and it works great for this particular application. JPEG 2000 has some potential advantages in terms of being able to compress the image more with fewer artifacts, be they blurring or other kinds of artifacts, for the same size output, same bit rate as the lossy compression people talk about. But from DICOM's perspective, we're agnostic to that because we use JPEG and JPEG 2000 inside DICOM to compress our tiles too. So you need to be very careful when you distinguish the compression scheme from the file format. Some people may call that wrapping the JPEG. So the SVS file is in essence a wrapper. I don't like that term because it has other implications that are not particularly germane here. But in essence, the JPEG or JPEG 2000 tiles are exactly the same. So when I convert an SVS file, TIFF file, into a DICOM file, I don't decompress and recompress and add more loss. I don't even color space convert. I just take exactly the same compressed bit stream and move it into place in the right place in the DICOM file. And I can therefore create both dual personality files that are both TIFF and DICOM at the same time. But we don't have the time to go into that. But those are the sort of things you can do. However,
like make a one-day workshop. So
yes,
if you ever have spare time, let me know. I'm happy to organize.
There is one more twist to her question, and this is that JPEG 2000 could be used in a different way. So instead of encoding one tile at a time and compressing it completely independently of all the other tiles using JPEG or JPEG 2000, you could take the entire slide, 60K by 100K pixels, and compress the whole thing using JPEG 2000 and use JPEG 2000's inherent tiling mechanisms or multi-resolution decomposition mechanisms. And that was an early proposal in our community, in the pathology community, I should say. Okay. But we didn't go that route for a range of different reasons, and that's a different use of JPEG 2000, and that may be what Maria was referring to.
Okay, so before I have another comment on the screen, but I need to ask. So you say, I just wanted to ask you, okay, shall we just all do JPEG 2000? And you just said no. For various reasons.
You can do JPEG 2000 if it offers you advantages, but it's much slower, much slower, both to compress and decompress than JPEG, baseline JPEG. So if you don't have a reason to use it, it just causes problems, frankly. If you have a reason to use it, that's another story. But that's a long and complicated.
I know discussion beyond the scope of today, but yes. I want to get a recommendation. Let's say I am a vendor starting from scratch, want to be DICOM friendly, DICOM everything. What's the path that you would recommend me to take? Like, I don't have any, obviously I want to be able to work with image analysis programs if I'm not one myself. But let's say I'm a scanning vendor and I'm starting a new scanning company and I want to do DICOM only. What do I do? Like, what do I choose? What like?
Well,
how?
you need an engineer who knows how to implement it and knows what devils are in the details. And most OEMs, to use the expression mentioned on the screen here, are familiar with that kind of stuff. So it's a known and quantifiable problem in terms of cost and what resources you need and tools, and there are commercial toolkits, open source toolkits, all that kind of stuff.
Okay, so do you or anybody offers consulting services for this?
Because lots of people do. Yeah.
Who does? Where can we find them?
I'm not here to advertise people's services. So yeah.
Okay, that's fine. Is there a place where you can find it? Because I want to let people know this is where you can find it.
There is an extraordinarily out-of-date list of consultants on the DICOM website that Nima runs. There was just a discussion today about updating that. They're not specifically knowledgeable about pathology, though, which is, doing DICOM and pathology and DICOM requires some special.
We need expertise. Pathology, and I'm happy for you to recommend someone who you trust. If it's not you, you don't want to. That's fine.
Well, we can talk about that some other time, but okay, we should make a list. We'll
How
take
about
that
we
as
make a list? Yeah, we make a list. Who wants the list?
Or get DPA to make a list. Yeah, get somebody who's paid to do this sort of thing to make a list.
Yeah, who wants us to work or DPA to make a list of DICOM consultant? Put a consultant in the chat or put a C in the chat. We don't want to type too much. put a C in the chat if you are interested in the list. And whenever it gets created, I'm going to know that you wanted it, and we're going to let you know where it is and who consults on that. Because obviously, it is beyond my technical understanding what is all going on behind the scenes, and honestly I don't want to get that granular.
No, exactly.
Because
you've
I
got a
want
day
to
job.
look at the image. I have
exactly.
a different job.
And that's the way pathologists should be able to do it. This should be a commodity, the same way it is in other specialties. Ken's question. Shall I turn to Ken's question?
Yeah, totally.
Yeah,
totally.
This is
let me read it. At Pathology Visions this year, 2022, several scanner OEMs said they were not implementing DICOM natively in the immediate future. Do you envision pathology scanners having to support DICOM to be successful? Yes.
Yes is the short answer. The same transition phase took place in radiology in the late 80s, early 90s. People would have a native format because they built their scanner from scratch and hand-coded their proprietary format, and they were reluctant to disclose that in those days because people believed they could compete on interoperability grounds. Try to sell a whole GE hospital or a whole Siemens hospital, and there's not a lot of that goes on anymore.
Didn't work with
no, it didn't work then.
Digital pathology either.
Yeah, it didn't work then. It won't work now. So the idea of having a converter that's supplied by the vendor. So when I worked with General Electric on this sort of stuff back in the 90s, we had converters in each scanner. So the scanner would produce its native format, and then it would have a converter that converted it into DICOM, and then it spat out the DICOM. And it was all in one box, and regardless of how many people were actually involved in producing that box, be it one OEM or a bunch of different suppliers, the customer got a turnkey solution that spat out DICOM. And then later, when this became a competitive advantage in terms of having interoperability using a standard, people used to talk about DICOM inside, which was a trademark of a particular, or
like
a
Intel
trademark
inside,
phrase.
Right?
Exactly, like Intel Inside. It was a rip-off of Intel Inside, frankly. And that was used as a marketing tool. And what they were saying essentially is we write DICOM straight away, and we don't dick around with our own proprietary format first with all the attendant workflow issues and complications and so on. So it doesn't. I don't really care whether the vendors say they're going to implement it natively or not, so long as they provide a solution for the customer. So if a vendor finds themselves at a proprietary disadvantage because they're still spitting out a proprietary format, then pair up with somebody who knows how to do this and produce a turnkey solution that the two of you have developed together, so that the customer buys one solution, even though it's actually two boxes.
So follow-up question. If we want to build artificial intelligence image analysis models on DICOM images, what are the implications of how this DICOM looks inside of DICOMs to the model development? Can this be transferred?
Right. Yes, exactly. So for example, if you're a researcher and you're trying to, get TensorFlow records or whatever it is you're feeding into your AI model, you're using PyTorch, you're using whatever else it is, then ultimately there's an array of numbers that's getting fed into the neural network. In what format that array of numbers is supplied to you is somewhat academic, as long as you can get it easily. Because the only thing an academic researcher cares about is getting the mechanical stuff done easily so that they can do the scientific stuff, which is what they're writing their PhD thesis on or whatever. So as long as your libraries that can read SVS or NPDI or TIFF or whatever can read DICOM too, then you don't care. If you want to use the metadata that's inside the file, so if you're an SVS user, you're kind of screwed because there isn't any useful metadata in the header. It has to come from out of band. If you're a OME TIFF user, well, maybe there's an OME XML file that actually has something useful in it, or not. Same is true with DICOM. You can ignore all of the DICOMishness of your source as long as you can manage those DICOM objects in the same manner as you manage your OME TIFF objects or your SVS objects or whatever.
What's an object in this context?
I'm using the word object instead of file to avoid using the word file, because we have multiple files for one pyramid. So think of the pyramid as a sort of object, if you like. I shouldn't have gone into all of that detail, but the bottom line is your library should take care of your input if you're an AI researcher, regardless of the format because that's the state of the art. That's what you have to do. You're stuck with Phillips files, SVS files, Hamamatsu files. You're going to have to deal with whatever you get, and standard files hopefully in future. But, and this is the big but, when you go into production, when you actually buy a commercial solution that does this AI stuff for you, which is what 99.9% recurring of pathologists in future will be doing, not writing this stuff themselves or doing their own AI development, then it just has to slot in. So in other words, the libraries have to, the AI algorithms have to be distributed in such a manner that they will seamlessly integrate with both the workflow and the bulk data transfer of input and output, such that the user doesn't see anything. The administrators, the IT people install the algorithm that they bought from somebody else. And if you're an AI vendor, then you have to fit into whatever platform that AI algorithm is being distributed in or is going to be used in. And that platform is going to take care of getting you the pixels you need and the metadata you need when you need it through some kind of API, which might be DICOM or might not be DICOM. So we have we have protocols in DICOM called DICOM Web, for example, which we use in our DICOM viewers that are web-based, that run in the browser.
Which we're going to show in a second.
Which we're going to show in a second. And those kind of things can also be used for AI. So if you want a set of tiles, you can request them through the DICOM web service that the viewers use, or you can get the entire file. If you're going to look at every frame, you might as well do that. So there's several different ways that you can use different parts of the DICOM ecosystem to get access to the information you need when you need it.
Okay, so we only have 5 more minutes to go. One thing to our audience, we are obviously not addressing all the questions that are coming from you, and thank you so much for all those questions. Keep putting them in, even if you're watching the replay. And by the way, if you're watching the replay, put an R in the chat so that it gets distributed to more people, but keep putting questions. I'm going to be looking into all the comments, and I'm going to be trying to work with David and with all the other sources to answer your questions. Obviously, there is a lot of questions. One more question before we go to the viewer, because this is also an important question. Do you guys have a DICOM workshop that people can sign up for, or is there a need to organize one? Because obviously we're like scratching the surface at my level, which is not too high of a level, but there are people who are asking really.
We do have outreach efforts which are intended to be educational. So, in the mainstream DICOM world outside pathology, there's lots of training because this is a commodity. I mean, every PACS administrator, every IT administrator in healthcare goes and does a DICOM course, a PACS course, and they learn all the basics.
Do we have a DICOM pathology course?
We don't, not as far as I know.
I mean, right?
We probably need one. In fact, there may be organizations that are working on offering this kind of stuff. There are professional societies that have educational outreach, and so organizations like SIM, Society of Imaging Informatics and Medicine, which doesn't have much of a pathology footprint at the moment, would be even just DPA could do this. This could be part of a track at PathVisions or something in future. The Association for Pathology Informatics. So many of the professional societies, the European societies as well. So definitely organization of educational material is desirable, but you need to distinguish educational material for pathologists, users.
Yeah, we want for pathologists.
Well, you do, yes. But then there's a whole group of other people that you need to support you in your digital infrastructure, and they need to be educated too.
I mean for pathology community, including image analysis, including scanning, DICOM for pathology use, not for me. I don't care if it's DICOM or not. Like, show me the image.
But to some extent, I would argue that all you need to do is know the word. You don't need a course to tell you. Just if it's not DICOM, don't buy it. That's the course.
Okay. But for the vendors, to support the vendors that are supporting us,
they need their own training. Yeah, they do. But
yes,
that's
they need
not the same
training, and I know that there is need for this. Who do we reach out to organize something like this? DPA?
As I say, DPA is a good organization because it's a combination of knowledgeable users and committed vendors. So I would recommend DPA for that.
Okay, then.
In your world, you have the ToxPath people too. So I mean, you have your own.
Yes, totally. Yes, we need this for ToxPath. I mean, I very selfishly, personally need it for ToxPath. Okay. Good. And now we just have 2 minutes to show the viewer. Do you have the viewer on your screen, or should I
why don't you do it? Because
I do it.
I'm not
gonna
sure I can share.
present. Let me see.
So while she's bringing that up, just for your interest, this is a project of the National Cancer Institute in the United States, the Imaging Data Commons project, and we share cancer images, both radiology and pathology, and so we needed a open source viewer. So this is Marcus
If it's on the
Daniel
screen,
Herman.
give me a yes.
Yes, it is.
Okay.
So this is Marcus Daniel Herman from Mass General, and this is an open source, pure Java, pure JavaScript, web browser-based viewer that does, your basic sorts of stuff. And it is using the DICOM web protocol to fetch the metadata and the tiles from a DICOM server. And it's actually talking to a Google server, if you can believe it. Google does healthcare, as you know.
Google does DICOM? Go Google.
Google does DICOM. Google does DICOM. And that viewer you were showing was talking to all of our images, which are stored in Google.
I wanted to show
as a public data
how
set.
do we get there. And I'm going to paste this in some description of this event and the recording so that everybody can go there. And what you just showed me, there is this thing with images. And when you encounter the H&E images, you click there, and then you're where we were before at this image. And you can find different other images as well. And Google supports that.
Google supports that. All of our images are taken from the Cancer Image Archive, TCIA, which has done hard work of gathering all of this stuff. We also have the NLST. We have the entire National Lung Cancer Screening Trial, Pathology, H&E images, as well as CT images, and so on and so forth.
So I can just go there and make screenshots of those images and post them.
You can go. It's all public. It's all open. It's all CC by 4 licensed. You can go there. You can do what you want with the images. You can do what you want with the software.
Put some likes if you like it. I like it.
and everything that we do is DICOM. It's DICOM or the highway as far as we're concerned. If your stuff is not DICOM and you want to be an IDC, we will convert it to DICOM for you, or
what's an
show you how to convert it. Imaging Data Commons. This is the Imaging Data Commons.
Okay.
This is part of the Cancer Moonshot Cancer Research Data Commons project. It's all part of that NCI infrastructure funded by the federal government.
Oh my goodness. See? I should know this, and I didn't know. So thank you so much for joining us today. Thank you for everyone who joined this broadcast live. I'm going to later convert it into a podcast. You can see it on YouTube, on Facebook. It's going to be there. And also, whoever wants this as a link, comment link, and I'm going to be sending you a page where you can get a link to this recording. Thank you. Thank you so much.
Thank you for having me.
I forgot to say one more thing. Put questions in, even if it's a replay. Put questions, because I'm gonna compile a document, like some DICOM broadcast questions and answers document. And obviously, if you want the list of people who can consult on DICOM, put a C, and let's see who I can reach out to. And everybody who wants to reach out to me about this, just reach out. Okay. Thank you so much.
And feel free to share my email, by the way, so that everybody can know how to contact me directly.
Yes. It's also, if everybody Googles you, David Clunie DICOM, your email is there and your website is there, but I'm going to put it in the description as well. Okay. Thank you so much for your time, and I will be in touch because there's a lot to talk about.
Bye-bye.
Bye.